Good morning. My name is Satya Samareddy. Today's talk, I'm going to talk about the principle involved in the hydrogen fuel cells, which is a green energy technology. So this is going to be more in the market in future. And also I will cover a brief introduction also along with the principle. So, so now I will share my, yeah. Yes, here it is. So, yeah, this is the introduction. You can see the title, Introduction Working Principle of Hydrogen Fuel Cells. So, here in the at present, we have three kinds of vehicles, all transportation vehicles on road. So, as we know already, petrol, diesel vehicles we have been experiencing for the decades. So we know the source of fuel is here petrol and diesel, right, or gasoline. So this is the source of fuel. And coming to the next type is electric vehicles. So this is now booming in the market. So what is the source here? Electricity. So electricity is stored in the battery. So these are called as a not only electric vehicles, battery vehicles also. There are some hybrid vehicles using battery technology. So this is now currently in the market. Tesla already been there, and in the car industry, and the scooters also have been came out. Wala scooters in India. So and other companies also have released electric scooters based on this battery technology. And the other type, third type, I think most of the people may not know, especially students or who are not aware of third kind of fuel. Everyone electric vehicle means battery technology. And another type, third one is hydrogen fuel cell vehicle. So in this, the fuel is hydrogen, and the device or technology used is a fuel cell. So this is called as a hydrogen fuel cell vehicles. So today I'm going to talk about the hydrogen fuel cell vehicle. How these are going to dominate the petrol diesel vehicles and slightly electric vehicles. So especially these are very important in heavy duty vehicles like trucks or maybe small passenger trains. So battery vehicles cannot dominate in this regard because they need a lot of batteries, which whose weight will be higher. The vehicle weight will be higher. That is the limiting factor here, and also refueling time. Just I will talk about this. In what hydrogen fuel cell vehicles already Hyundai, Toyota, Honda already released it in the respective countries, Japan, Korea, South Korea, and in US, in Europe as well. So, and there they are giving for lease this hydrogen because it's not affordable, it's expensive. So, but the technology already there in the market, it's existing, vehicles are there in the market. So, here, how the hydrogen fuel cell are more beneficial, more advantages over petrol and diesel and electric vehicles. This I will give it here. So here the efficiency is the first important factor here. So the efficiency up to 60% we can go in hydrogen fuel cells. Whereas what we have been utilizing, the petrol vehicles or diesel vehicles, we see only they are 30% efficient. This is one of the impact factor. Double the efficiency of these petrol vehicles. That is one important factor. And the second most important is for the environment. So as we know, greenhouse gas emissions are mostly prominent from the conventional vehicles, what we have been using over the decades after industrialization, right? So, but here in hydrogen fuel cells, no CO2, no other greenhouse gases, zero. It's zero, completely zero, because the source is hydrogen. There is no carbon. And in secondly, how these hydrogen vehicles are better than electric vehicles. See here, electric vehicles requires long refueling time, maybe 30 minutes or 20 minutes. So, and also it cannot run for a long time also. So it can go up to 300 or 350 kilometers. However, in hydrogen fuel cell or whatever the vehicles based on hydrogen fuel cells, they can be filled with hydrogen fuel like diesel or petrol. How we fill within a minute. Same way, it's a gas like gasoline. We can fill it. The same way, long driving distance. So once we fill it, the tank of the hydrogen, which is fixed in any hydrogen fuel cell car or any other vehicle, so we can go up to 600, more than 600 kilometers. It's already proven. So the cars are existing already. So yeah, here I'm going to talk why this is more interesting, because see, I'm going to talk about hydrogen fuel cell as this is a topic in this talk. In India, on 2019, in 2021, Independence Day, Prime Minister has announced that our future energy is going to be hydrogen, based on hydrogen. We have to rely on this. This hydrogen is available everywhere. Hydrogen element, it is the most richest element in the universe as well on Earth. Total atmosphere, all considering the factors on Earth. So this is the source, but it's very difficult to extract the hydrogen gas from the hydrogen containing sources. That is the biggest problem here. Next, I will talk about the fuel cell car, how it runs. Right? This is the fuel cell vehicle. Here it is. And in this, you can see how the hydrogen tank is fixed, like a petrol tank or diesel tank at the back side of the car. Here you can fix it. And this is the schematic. And this is the device, fuel cell device. You can see this mainly contains the anode, membrane, and cathode. These are the three main parts. For simplicity, it is given here in the schematic. So there are other components also there. These are three are the main components of fuel cell. That's why we have it is shown only this one. So anode side hydrogen is fed, and cathode side oxygen is fed. Like oxygen must be required. It's oxygen. Any fuel, oxygen is required. Even for internal combustion engines like our petrol or diesel cars, also we need oxidant from oxygen. So in the same way, here also oxygen is required. So the hydrogen gas is pumped out from here. And this is the technology. What I'm going to talk now, the principle involved in this. This is the short introduction, how these are beneficial for the future dominating renewable energy source. So this is one of the. So here the principle I will talk here. The fuel cell is a electrochemical device. So the technology of fuel cell is based on the electrochemical process. So this fuel cell, this is schematic. This converts the chemical energy into electrical energy by fuel cell technology through electrochemical process. So here, where is the chemical energy comes from? Chemical energy comes from the bond, single bond between hydrogen and hydrogen. That is what hydrogen gas is, right? One hydrogen molecule, H, single bond H. What is the energy of that? The bond energy of that single bond is 432 kilojoule per mole. So this energy is converted into electrical energy in presence of oxygen. See, 2 moles of hydrogen reacts with 1 mole of oxygen in gaseous form. Both are in gaseous state. Then they produce electricity and the water. It's a simple reaction. H2 plus O2 gives water. Everyone knows it. But the most important thing here is the electricity. Electricity. This is, we have to extract it. So in this, the voltage is developed is 1.23 volt. So theoretically at room temperature, the observed voltage is 1.23. Like each battery has a 1.2 battery, 1.2 volt battery. We know it 1.5 volt battery. Same way, each cell of this fuel cell gives the 1.23 theoretically at room temperature, or ideally it is not possible. So it is less than 1.23. So here the fuel is hydrogen, right? So how? What about our other fuels? Like just it is worth to mention here. That's what I want to show a small comparison here. From hydrogen, we are getting no carbon because there is no carbon in the reactants, isn't it? No carbon. So how a carbon product will form? No carbon. No, no carbon product in the product, right? So whereas in case of petroleum gases, diesel and kerosene and other even gasoline, it's not reflected here. It's not displayed here. So whatever it is, they the carbon source existing in this, the hydrocarbons existing in this type of oils, different kinds of oils, there and crude oils, right? They are extracted. So they are not single molecule. They are different kinds of molecule exist in a particular kind of oil. So the range is given C4 to C12 for petroleum, diesel C8 to C21. For example, let me take an example of diesel. One mole of C8 or minimum we can take. If you take C8, 1 mole of C8 molecule, the hydrocarbon reacts with oxygen in presence of oxidant. How many moles we get it? 8 moles of CO2 we will get 8 times. But in case of this hydrogen fuel cell technology, no, it's zero. See, and in case of others, see C8 to C34 also. So it's huge amount of carbon dioxide and other greenhouse gas, carbon monoxide, sulfur dioxide, nitrous oxide are the prominent uh, causes based on this. So these are all emitting into the Earth's atmosphere and causing the global warming. So there is a big threat for the human living, other living systems on Earth's crust, right? Earth's atmosphere. So due to that, we need to work on other alternative sources like renewable energy. There are many technologies came. So at this time comparing this one, and so let me go into the principle involved in this, how it works. To get the idea, I just given an example. So here in this is the device schematic. How it works, I'm going to talk about this. The hydrogen fuel is fed into the anode, and oxygen comes from the cathode side. So maybe from the air or pure oxygen can be. So these anode and cathode are both are connected through a electrical cable. See here. So if any electron generated here can pass to the cathode through this external circuit, electrical cable. And another way, these anode and cathode are like a plates, like a square or rectangle plates of different size, maybe 10 centimeters square, 100 centimeters square, or even 500 centimeters square. The plates. Okay. So both anode and cathode layers, I can talk as a layer, and these two are fixed. In between, there is a membrane. It's a permeable membrane, proton exchange membrane. We call it as proton exchange membrane. The membrane inside of same size, the size of the anode and size of the cathode. The membrane size also should be same. So the membrane should allow only protons, means H plus ions, not the electrons. The property of the membrane is in such a way that it should not allow the electrons and it should only allow protons. Due to that, it is called as a proton exchange membrane. It can exchange. For example, proton is here at the anode surface. It's formed here. So this proton will pass through this permeable membrane towards the cathode. That's the property. So anode and cathode are separated by this membrane without any electrical conduction through this path. So in case membrane is not there, what happens? So electrons will flow directly here and short circuit will be the obvious way, right? It's obvious short circuit will going to happen. So definitely the anode and cathode should not touch each other. So it should be separated by some kind of any kind of membrane which can allow the protons. The property of the membrane should allow the protons. Generally in PEM technology, this is proton exchange membrane fuel cell. Nafion is the membrane is generally used. It's called as a Nafion. Okay, so we'll talk about that later. What are the different kinds of membrane existing? This is what about how it works. When hydrogen is passed through here, pass through plus the anode, it will split into H plus and electrons. See here, at anode there is an oxidation of hydrogen. How hydrogen will dissociate into protons and electrons? It's simple. It's a half cell reaction. One of the half cell on anode at the anode. So these protons here and the electrons are here existing. As long as you pass the hydrogen, we have a hydrogen tank, you're just passing. So 1 mole of 2 moles of hydrogen gives 4 electrons, 4 hydrogen. 1 mole of hydrogen will give 2 electrons, 2 hydrogens. As long as you have n number of moles, you will have n number of 2n number of hydrogens and 2n number of electrons. So as long as we have hydrogen, we will get it. So the membrane only allows these protons, and the electrons will come from the external circuit, as I explained clearly. So this travel from anode to cathode. So here. So I want to tell you one thing. Why it is called as an oxidation, hydrogen oxidation reaction, right? Here the reactant is hydrogen and it dissociates into proton H plus. The oxidation state of hydrogen is 0 here, and in the product side the hydrogen elements valence state is plus. So it's increasing valency. So it's called as an oxidation. Hydrogen is oxidizing. So this is called as a hydrogen oxidation reaction. Simply it's called as a HOR. So another point I want to talk about this is catalyst. Okay, so let us wait. I will talk later. Yeah. So when the protons are coming from anode to cathode through this membrane, and at the same time electrons are coming through this external circuit, these two electrons and protons will react with oxygen. Oxygen will be passed from cathode side. So this electron and H plus ions will react with the oxygen. So it will give, see the reaction here. So here oxygen reacts with the 4 moles of H plus ions and 4 electrons. Okay, 2 moles of water. This is called as a 4 electron pathway. Direct 4 electron. Immediately the oxygen, 1 mole of oxygen will react with 4 times of protons and 4 electrons. There is another path called as a 2 electron pathway. What is 2 electron pathway? So first initially 1 mole of oxygen reacts with 2 moles of electrons and 2 protons, it gives peroxide. And again peroxide have to react with again 2 moles of proton and 2 moles of electron. It gives water again. So generally 4 electron pathway is more preferred than 2 electron pathway because this is a 2-step reaction. That is one factor. It takes time. And second step is second much important factor is this the formed intermediate like peroxide, it poisons the cathode or cathode catalyst, I can say. So I will talk about that catalyst here. So due to that, 4 electron pathway is mostly preferred. So we should avoid forming the H2O formation. And why this is called as a reduction, cathode reduction. Why I said reduction means oxygen in reactant side, you can see oxygen in zero oxidation state, and it forms water as a product. So in this, you see oxygen's valence state is negative, -2. So 0 to -2 is reduction, decrease in the valence state. So this is called as a reduction reaction. Oxygen is reduced to water. Oxygen reduction, or simply we call as a ORR, oxygen reduction reaction. In this process, when electron and H plus O2 react with water, water is the byproduct here, and electricity is the major product. We can say product, right? Here I mentioned here, electricity is the major. We can utilize it, the electricity, as long as you have a fuel, you have a stable membrane, then you have this electricity passing. So if you keep anything, any energy appliances, so you can utilize it based on the voltage is developed. The voltage is developed here based on the potential difference from anode cathode. Between anode and cathode, if you check the potential difference, theoretically it should come 1.23 at room temperature between these two for a single cell. So if you want 100 volt, what we should do? These all single cells can be connected in series, 100. So it will become 100 volt or more than slightly. Theoretically, it should be 123 volt if it is 100 cell, because it is 1.23 volt. Ideally, it never forms, never develops. Okay, let us talk later. That's another topic. So this due to that, this is called as a proton exchange membrane fuel cell, because proton is exchanged between the anode and cathode by through a membrane. So this is called as PM fuel cell technology. And here I want to mention a very important factor, very important. So the reactions, either anode or cathode, are slow, generally slow reactions. The activation and energy is high, so it needs a catalyst, so which can hasten the either hydrogen oxidation and oxygen reduction reaction at both sides. So the most widely studied or best catalyst is the platinum till date. So even commercially, people are using commercial fuel cells. Fuel cell based cars are existing already on the road, right? Still, they are using platinum based catalysts only. Till that makes this technology makes expensive. Due to that, still though the fuel cell technology is existing over the years, but still it's not become popular because of this expensive uh, and the slow kinetics in this reaction, like oxygen reduction reaction. So I will talk. So platinum is required, right? And after platinum, the activation energy is decreased. This is the layer. You can see anode side, the black layer is released. So this layer is called as a platinum catalyst. It's coated platinum based. So platinum group means platinum based catalyst. Platinum group means rhodium, iridium, osmium, ruthenium. These are all active for this reaction, but especially the platinum content should be there. So after studying, after research, so the finalized catalyst is the platinum group. So here this layer is there, coated with platinum slurry, platinum catalyst slurry. In the same way, cathode side is also same. But compared to anode side, the cathode side has the more sluggish kinetics. Cathode has more sluggish kinetics because oxygen reduction reaction is the sluggish process. Even though you use platinum group process, still it's slow reaction. So it requires high amounts of platinum loading. which makes the fuel cell technology expensive. That is the reason. So most widely studied reaction in this fuel cell technology is oxygen compared to hydrogen oxidation. This is completely optimized. Or still people are studying to improve it, but compared to this, so people are not able to improve the performance. So people are trying for other alternative materials. So people have tried, the researchers, scientists among the globe, so have tried it, but still not able to improve the performance. It's not up to the mark. Due to that, people have to rely on, industries have to rely on platinum-based catalysts only. But in the direction to work on reducing the platinum amount. How to reduce the platinum amount, right? So platinum can be alloyed with other metals. So alloys of platinum also being researched in the literature. Yeah. So in this technology, finally, what I want to say is there are compared to all, there are two important things too. One is the efficiency of the membrane and and uh, the, the oxygen reduction reaction at the cathode are the major barriers in fuel cell technology. Even PM we have Nafion, people are using that, but compared to that, the research is still underway. How to improve the proton conductivity of a membrane, Nafion membrane or other types of membrane. That is some kind of study. So maybe in future I will talk about that. And the major concern about here is 40% of the cost goes here for the platinum loading at cathode side. Cathode side. So people need to think and work towards this reducing the platinum loading and are looking for other alternative catalysts to replace the platinum at the cathode. So that's what I want to talk here. Thank you very much for watching this video.